Assalamu alaikum, students. Students, in today's recorded lecture, we are going to study atomic radius and ionic radius, right? The radius of an atom, the radius of an ion. The radius is actually the distance of the valence electron from the nucleus. Distance of the valence electron from the nucleus. This distance depends on number of shells. More the number of shells, bigger would be the atom. Second, on the nuclear attraction for the valence electron. Look, the number of shells, the nuclear attraction for the outermost electron, and shielding electron. What are shielding electron? The electron between the nucleus and the outermost, right? The electrons, this is the nucleus, these are the in-between, and this is the outermost. The electron that are in between the nucleus and the valence, right? So, actually, the electron that are called shielding electron, they shield or they protect the outermost electron from the nucleus effect, the nuclear attraction. Like suppose, if the teacher is the center and there are students, if there are more students in between, so the distance or the interaction of the teacher with the last shell, with the last row would be less, because the students who are sitting in between, they are coming in between the last row and the teacher, right? So therefore, I think in online, me and you are direct in contact. So listen carefully. Like, it depends on you that with how much interest you are listening, right? So that's now your interest. Like I think showing my full interest, but now it depends on you. So to explain atomic radius, coming to the topics, coming to the topic, I'm going to explain the atomic radius. So for that, I'm going to share the screen. But when I'm sharing the screen, you guys are supposed to like, subscribe, and share my channel. Okay, go do this like right now. So I'm sharing the screen with you. This is 3, 2, and 1. Okay, now atomic radius. What is atomic radius? Is actually okay. Atomic radius. I will share the notes with you. Don't worry. You know that my notes are available on my website, right? Atomic radius. This is nucleus. And these are the outermost electron. The distance, this is what? Atomic radius. And you know, atomic, my A is small. Atomic radius depends on what? Depends on number of shells. Shielding electron and nuclear charge, as well as nuclear attraction for valence electron. Now you know that more the shells, look, one shell, two shell, nucleus, one shell, two shell, three shell, nucleus, one shell, two shell, three shell, four shell. Definitely more the number of shells, bigger is the atom, like it's obvious. Now what is shielding electron? Nuclear charge. What is nuclear charge? The charge on the nucleus, the protons. The attraction of the proton to the outermost is called nuclear attraction for valence electron. But now what are shielding electron? You know, the shielding electron are the electron. Look, this is nucleus. This is first shell. Now look, these are electron, electron, electron. And suppose these are outermost, like you can even go for this one, group 4 element. No. This is nucleus. These are outermost. These are what? Outermost. And you know, these are the in between. These are called what? The electron between nucleus and outermost. Huh? These are electrons between nucleus and outermost. These electrons, they repel each other. They repel each other. So the nucleus actually attract all these. The nucleus attract and they repel. So these are two opposing forces, they balance each other. The electrons are repelling, the nucleus is attracting, the attraction and repulsion, they are trying to balance each other. More the shielding, more repulsion, more nucleus attraction is needed to overcome repulsion. As a result, they like the valence are then held by the nucleus. Like these repelling forces are actually controlled by the nuclear attraction. They're balanced by. So more the shielding electron. As a result, the nuclear attraction for the valence is what? Lowered. Like I told you, this is the teacher. This is the last row. More the in between, more effort is used by the teacher to convey the message to the last row. Yes, exactly the same. Therefore, they are called what? Shielding, protecting electron. So they are protecting what? They are protecting the valence from the nucleus. You know, they also repel. They also repel. But the repulsion of the inner one, they repel this, they repel this, they repel to the other, they repel to this. Like the repulsive forces by the inner electron is more as compared to outermost. So nucleus attract, shielding electron actually repel. The repulsive forces are balanced by attraction. Now one thing. I'm going to copy it from the notes. Atomic structure. This is made by me. I'm going to copy. I want to show you one thing. Look, this is down the group. What is happening? What is happening down the group? In beryllium, there are 4 protons, 2 and 2. In magnesium, there are 12 protons, 2, 8, 2. So what is the difference? Are the proton increasing? Is the attraction increases by the nucleus? Yes. More proton, more is the nuclear attraction. There are 2 shells. There are 3 shells. If you look, 4 proton, 12 proton, and then what? 20 proton. Now, 2 and 2. This is what? 2, 8, 2. This is what? 2, 8, 8, 2. So what you can see? Are the number of shells getting more? 3 shells and then 4 shells? More the shells, more is the nucleus of the valence. More is the distance of the valence electron from the nucleus. More is the distance of the valence from the nucleus. Now, you can see how many protons are getting more. How many protons are more? 4 to 12, 8 protons. And you can see 8 electrons are also more. What are these electrons? Are these valence electrons? No, these are shielding electrons. This is shielding, this is shielding, this is shielding. Is there any change in the valence? No, there's no change in valence. The valence is what? Same. But are the shells more? Yes. Where? Down the group. The shells are more. The shielding electrons are more. The valence electrons are same. Now, when the shielding are more, the repulsion is more. When the protons are more, the attraction is more. 8 proton more, 8 electron more. What about this? 12 to 20. 8 proton and 8 electron. So what you can see? 2 shielding, 2 and 8 shielding, 2 and 8 shielding. Are the proton increasing? The shielding electron increase, proton increase, shielding electron increase, no change in the valence except the valence is going far. Look, the proton are increasing but shielding increase. Proton increase, shielding increase. Attraction increase. Repulsion equally increase. Look, 2 and 2, 8 and then 2, 8, 8. Proton increase, shells and shielding increase, attraction increase, repulsion equally increase. They balance each other. The attraction and the repulsion balance. Balance means they become equal. They become equal. When the proton are increasing but their effect is cancelled, like it's kind of the same thing, then why the nuclear attraction for valence is getting less? Because for the same attraction, the valence is going far. For the same attraction, the attraction is the same. Why? Because the shielding is more. The attraction is the same because the shielding is more, proton are increasing, but attraction is the same. Now, what is the issue with the valence? They're getting far. So the same attraction is less for the far electron. So what you are supposed to say? Proton increase, shells increase, proton increase, shells increase, shielding increase, attraction increase, repulsion increase, they balance each other. Nuclear attraction for the valence is getting less because they are getting far. So how you are supposed to write? See, look what I have written. What What is the atomic radius? Distance of the valence electron from the nucleus. It depends on number of shells, shielding electron, protons, attraction for the valence. And what I've written, shielding electrons, the electron between the nucleus and the valence. They repel each other, therefore they decrease the nuclear attraction for the valence. Shielding means they shield the valence electron from the nucleus. Down the group, proton increase, 8 proton, 8 electron, 8 proton, more 8 electron, more 18 proton. The number of proton increase, shielding electron increase equally, both increase equally. Therefore, they outweigh each other, they balance each other. But valence electron are getting far. Therefore, nuclear attraction for valence electron getting less because they get far away, more shells. But what happens across a period? This I've repeated the same thing again. Now across a period, what you can see. Sodium, magnesium, aluminium, silicon. This is across a period. 11 proton, 12 proton, 13, 14. Are the proton increasing? Yes. 11 proton, 281, 282, 283, 284, 285, 286, 287, 288. Are the proton increasing? Yes. Across a period. Are the proton increases down the group? Yes. Is there any change in number of shells? No. Is there any change in the shielding electron, the yellow, the in between, the shielding electron? Remains same. The proton increase, the shells increase, and shielding increase. The proton increase, the shells and the shielding remains same. Now, when the shielding is same, the repulsion are same. The repulsions are same. The shielding are same, the repulsion is same, the proton attraction is increasing, the effect of the proton is getting more, the attraction is more. Look, the proton increase, proton increase, proton increase, but 2-8 remains same. The 14 proton attract the electron more is the result when the nucleus attract more, the size is getting small, it shrinks. The atom shrink. Do you get? Number of proton increase, nuclear charge increase, shell and shielding remains the same. Nuclear charge is the charge on the nucleus, which is number of proton. The nuclear attraction for the valence increase, the size of atom is getting small. In the periodic table, if you go down the group or across a period, the nuclear charge will always increase. Proton increase, but its effect for the valence is decided by the shielding electron, the number of shells, or the distance of the valence electron from the nucleus. Down the group, proton increase, across a period, proton increase, but the effect of the proton for the valence electron is decided by the shielding electron, right? So if the shielding electron increase, they balance the nuclear attraction. They cancel out. The nuclear attraction for the valence decrease because the valence gets far. And across a period, proton increase, the shells are same, the shielding are same. Therefore, the nuclear attraction for valence increase. Look. Down the group, size increase, size increase, size increase. Across a period, size decrease. See? So you can see that in periodic table. In the left, this side, larger, and this side is what? Smaller atom. Down the group, atomic radius increase. Across a period, atomic radius decrease. And your next topic is what? Ionic radius. Now, see, I'm going to explain this first. I hope you understand. Ionic radius. Ions are of two types. I'm explaining just. Cations and anions. Cations are made by loss of electron. In cations, protons are more than electrons. If protons are more, nuclear attraction is more. So size of cation is smaller than atom. Cations made by loss of electron. So the electrons are less, the protons are more, the attraction is more, shrink, its size is smaller than atom. Anions made by gain of electron. So protons are less than electrons. Electrons more, repulsion more, nuclear attraction less. Nuclear attraction less. When electrons are more, the repulsion is more, the attraction is less. To minimize repulsion, the electron will get closer or far, bit far to minimize repulsion. The size of an ion is bigger. An ion is large than its atom. See? Suppose this is Na and Na plus. This is O and O minus. How can we compare? This is 11 proton, 11 electron. 2, 8, 1. This is 11 proton, 10 electron. 2 and 8. So what is your conclusion? Definitely two shells, more proton, more attraction. Proton are more than electron. When the proton are more, the attraction is more, the size shrink, smaller. 8 proton, 8 electron. 8 proton, 10 electron. The electrons are more. The protons are less. The nuclear attraction for electron is less. The repulsive forces are more. The size of an ion is bigger than atom. This one is large, small. Its size is large. Its size is large. Look. Cations are made by loss of electron. Nuclear attraction for electron is more. Protons are more. Attraction is more. Size of every cation is smaller than atom. 2 plus 12 proton, 10 electron. Right? The electrons are less, more nuclear attraction. Anions. In an anion, electrons are more than proton, more inter-electronic repulsion. The nuclear attraction is less, the size of an ion is larger. Look, Na plus. Na is bigger, Na plus is smaller. Mg is bigger, Mg2 plus is smaller. Chloride is larger, chlorine is smaller. Sulfide is larger, sulfur is smaller. Do you get? Now, across a period. Look, if we look at any group for ions even, Like suppose Be2 plus Mg2 plus down the group, calcium 2 plus 2 to 8. It's obvious that down the group, whether it's cation, whether in any group, since number of shells are more, when the shells are more, the size will be bigger down the group. Across a period in ionic radius, you know what is happening? Across a period. Look, Na plus, Mg2 plus, Al3 plus, Si4 plus, 3 minus, 2 minus, Cl minus. This is period 3. Look, 11 proton, 12 proton, 13 proton, 14, 15, 16, and 17. What about electrons? 1 plus 10 electron, 2 plus 10 electron, 3 plus 10 electron, and 4 plus 10 electron. But what about this one? 3 minus, 15 plus 3, 18 electron, 16 plus 2, 18 electron, 18 electron. You know, they make what? They make anions. They're gaining electron. And these are making what? The silicon could be plus 4, could be minus 4. There's possibility of both, but in most of the question, it's just plus 4. So I'm writing plus 4. Now, if you look at these, are the electrons same or different? In these same electrons? When electrons are same, keep in mind, when electron, I want to write this in a larger size. If, look, electrons are same, the deciding power or force is proton. More proton, more nuclear attraction, and smaller is size. More proton, more attraction. This is when the electrons are same. When the electrons are same, more proton, more attraction, smaller size. Now look, are the electrons same? Are the proton increase, attraction increase? Of course. Size decrease. Size decrease. Why the size decrease? Because the protons are getting more, the attraction is getting more. These are 10 electron, 2 shells. 2 shells. And these are 18 electron, 3 shells. So what is going to happen? These are 10 electron, proton increase, attraction increase, the size decrease, but after 10, after silicon, would there be a big jump? Yes. Why? These are all having 2 shells and these are all having 3 shells. There's a big jump because the quantum shell is more. When there are 18 electrons, again the proton increase, the size decrease, attraction increase. Look, what you are supposed to write? The electrons are same, but the number of proton and the nuclear attraction for the valence electron increase. The ionic radius decrease. There is a quantum shell increase. This is 288. Quantum shell increase. There's a big jump like this. Look, from sodium to silicon decrease because proton increase. And then there is a sharp rise because quantum shell. There are 2 shells and there are 3 shells. They are bigger. when there is a big jump, right? And then again the electrons are same. Well, what is increasing proton? They're getting smaller. Huh? So size of these are smaller than these. Yes. Why? Because they have two shells and they have three shells. But if I compare these with each other, and if I compare these with each other, proton increase, size decrease, size decrease. I hope you understand this topic. The next topic is ionization energy, which I'm going to cover in the next lecture. So now you guys are supposed to like, subscribe, and share my channel. Bye.